Alright, let's take a look at the general inverse functions. They say that the inverse functions of multiplication, such as division and square rooting, can be implemented by placing a multiplier in a feedback loop of an op-amp. So there's an op-amp and there's the multiplier, and we are taking the feedback loop from W, the output, pin number 7, and that's going to hold a 10 kilo ohm resistor back to the inverting input of the op-amp. And then we measure the output, the result of our square rooting. This is the formula for it. The square root of minus 10 times the injected signal that we put. That's the result that we should get. So if for example say I put 0.5 volts, because the input signal should be less than 0. So if I put minus half a volt, that would be the square root of minus 10 into minus 0.5 volts, which should give me about 2.23 volts on the output. So let's wire it up and take a few measurements to see if those are the results that we get. This is the operational amplifier. We will take from the minus 15 volt rail that we're supplying the entire circuit with, put it through that potentiometer, and calibrated it to give us minus 0.5 volts output. And we should read from over here the square rooting product of it, which is 2.23 volts, around that much. So the circuit is sensitive, probably because of all of that, but I was getting the result we're expecting. So let's take the measurements. And on the input, just before the resistor, that's minus 0.5 volts. And on the output, I will receive 2.4 volts, 2.23. So that is exactly what we are looking for. A little bit of offset and noise, like 2 millivolts, but that's fine. Let's try a different value. Try 0.7. So if I take the second square root minus 10 times minus 0.7, what did we do wrong? Ah yes, I know what I did wrong. I was pushing this minus. It should be this minus times 10 times minus 0.7, 2.6. So I'm getting on the input minus 0.7 and on the output 2.6, 2.8, 2.7. Okay, that's very close. So that's the multiplier circuit. We're finding the square root plus the certain offset that's given by the Zener diode. Remember, the 10 volts that we are accounting for in the square root is coming from the Zener diode. Then we're multiplying it by the input voltage and we get the inverse. So that's the circuit and those are the results.